Hi everyone, welcome back to my channel. In this video, let us understand how to use Desmos for effective teaching and learning. The outline of presentation is prescribed here. Initially, we'll start discussing with the sinusoidal waveform, then how to set Desmos. Next, uses of Desmos for engineering application, how to generate three-phase waveform, finally harmonic signal generation. Now let us understand how to draw sinusoidal waveform. We know that for the sinusoidal waveform we need a magnitude as well as frequency of oscillation. Now V1 is a signal, that is sinusoidal signal I am going to plot. Vm is a magnitude of the given signal, then sin omega t, where omega is frequency of oscillation in terms of radian per second. Here omega may be represented as 2 pi f, where pi is 3.14 and f is frequency of oscillation. Then for a 50 Hz signal, if you calculate omega is going to be 314. Then I am taking simple example of V1 is equal to 10 sin 314t, where 10 is your Vm, that is magnitude represented here, and 314 is omega, which is represented here. So based on this, I am going to plot a waveform. I will be finding the waveform like this. So this is your Vm, that is equal to 10 because magnitude is 10. Okay. Then 314t omega, that is frequency of oscillation. So this sinusoidal waveform for one complete cycle means right from this point to starting point. So this is frequency of oscillation, or I can say 50 Hertz. 50 Hertz, or in other words I can also call this as 20 millisecond. Okay, now let me straight away go to Desmos and I'll explain how to plot this and understand this curve. Open Google, type Desmos, then go for Desmos. Let's learn together this link. Then you can get this page, graphing calculator. Choose this. There you go. You can get Desmos graphing calculator. No need to sign up here. Without signing also you can use this Desmos. Go to graph setting. Select degrees. You can also use radians. As of now I'm going for degrees. According to my example, I have chosen 10 as a magnitude, so that y-axis I am choosing here as 15 in both negative as well as positive direction. X-axis, for the sake of clarity, I am using -5 to +5. Then, as per my example, I am going for V1 to generate sinusoidal waveform. 10 is a magnitude, sin omega is 314t. So have a look at this waveform. I have generated sinusoidal waveform with the magnitude of 10. Then the signal here, one cycle represents 50 Hertz or 20 millisecond as I represented earlier. Okay. Then this is actually one single phase waveform. Suppose I want to generate three phase waveform here. So I'm going for the second phase, copy pasting this. with minus 120 degree. Then similarly I can go for a third waveform, V3 with plus 120 degree. So have a look at this. Three different waveforms has been generated representing three phase systems. Okay, red. You can change this color also. This blue color. Go to setting. Click on this. Let me choose yellow here. Done. R, Y, and this color I want to change it to blue. You can change it. Done. Okay, now you can able to see this red color waveform starting from 0. Okay, and both blue and yellow color 120 degree away from this red color waveform. That is what normally we see in three phase systems. For sake of clarity, I am representing only red and yellow here. Now have a look at this. Red color waveform is leading 120 degree from yellow color waveform, or in other words, yellow color waveform 120 degree lagging from red color waveform, or R phase I can say. Then coming to red and blue. Okay, so this blue color waveform, that is B phase, leading red color waveform by an angle of 120. That is what this 120 represents here. So this is what three phase waveform. Okay. Then let's move on to harmonic signal generation. Okay. Say for example, I am taking V4. I want to generate third harmonic signal here. So 10 divided by 3, 3.33 sin omega t. In fact, 3 times omega t I have to consider. 314 t. I have to consider 3 times of 314 t. Let me disable these two waveform. In fact, all three waveform. Let me see. 3 times 150 . Sorry, here it is multiplication symbol, not dot. Okay, so though it is representing dot, we have to use multiplication symbol. 3 times of 314t. So this is what third harmonic signal. Then let's combine fundamental here is V1 plus third harmonic is V4. So let me combine these two here. Let's represent this as V5. Have a look at this waveform. Okay, so I'll just go for my fundamental waveform. I just remove these two. My fundamental waveform is in red color. This is 50 Hz signal. Okay, now I'll go for my third harmonic signal. My third harmonic signal magnitude is 3 times lesser than my original waveform, and in terms of time period or frequency of oscillation, 3 times greater. That is what the 3 is multiplied here. So instead of 50 Hz, you may get 150 Hz. So have a look at this waveform. 1, 2, and 3. Okay, so 3 cycles available, okay, on a single cycle of fundamental waveform. Okay, so fundamental waveform is 50 Hz signal. Third harmonic signal is 150 Hz signal. That's the reason why you are finding so 3 cycles on a fundamental waveform. Okay, so when I go for sum of this fundamental and third harmonic signal, so have a look at this one. So this block color representing your fundamental plus third harmonic signal. Let me choose only third harmonic signal added with fundamental. Okay, so how can I say this signal has only third harmonic imposed to the fundamental signal? So you can able to see this. Okay, so one wave shape change. Okay, then again second wave shape change, third wave shape change. Okay, so three changes in wave shape on one half cycle. So this is representing fundamental signal added with third harmonic. In order to have clear understanding, let's go for fifth harmonic signal. Okay, so I'll take this with some other name, 1 3. Let's go for V5. What is V5? So 5 times lesser than magnitude, that means 2 sine. So in terms of frequency, 5 times greater. I'll just copy this. Five times greater, 5 multiplied. Okay, so now have a look at this waveform. I just remove this black color because black color representing your third harmonic added with your fundamental. Now we are simply going for fifth harmonic signal alone. Okay, fifth harmonic signal alone. So magnitude wise 5 times lesser, frequency wise 5 times greater. Let me check it. So this is one complete cycle. So between this point and this point, that is 0 0 to 1.146 comma 0, between these 2 points, you could observe that 1 2 3 4 5 different cycles. So 5 different cycle within one cycle of fundamental 50 Hz signal. Okay, now I'm going to combine these two. Okay, so fifth harmonic signal V5 is added with V1 fundamental, that is fifth harmonics is added with fundamental signal. Let me take down this is V15 just to represent fifth harmonic imposed on fundamental signal. Now have a look at this 5 different changes. So this is first wave shape change, then slightly drop in wave shape, then further spike increases, then drop, further slight up, then again decreases. 5 different changes you could see here. Then if you move it closer to the waveform, then you could see this first change, second change, third change, fourth and fifth change. So this is what fifth harmonic added with your fundamental signal. Likewise, you can generate harmonic signals here. This tool is an effective tool for teaching as well as learning process. A teacher can use this effectively to teach or to deliver their lecture to the students, or the students can use this particular software to understand various signals, especially in engineering field. I hope this concept is useful for you to elaborate the signals in different way. I will come up with a different lesson in the next video. Till then, bye bye.